In this problem, a drug company has developed a flu vaccine and they're deciding between two different strategies, strategy A and strategy B, for full-scale development. And so the first thing we want to do when we get a question like this is to draw a timeline. So strategy A is going to require a $1 billion investment up front, minus $1 billion. And so my units are in millions of dollars. And it's going to generate $500 million in year 1, $400 million in year 2, and $300 million in year 3. On the other hand, strategy B is going to require a much smaller upfront investment, and this investment is going to be spread out over the first couple of years. So we require a $200 million investment in year 0, $200 million in year 1, and it's going to generate cash flows of $300 million in years 2 and 3, respectively. And so the question is, which one of these two projects should they go with? And so in order to answer that question, we're going to calculate the net present value, the NPV of these two different strategies. And once we've calculated the NPV of the two strategies, we're going to be able to compare which one has the greatest amount of value. And so in this problem, we're told to assume a discount rate of 5% per year. So this is going to be give us the exchange rate that we're going to use to discount these future cash flows to time 0. So let's start by calculating the NPV of project A. So the first thing is it requires a $1 billion investment up front. And then we start discounting these future cash flows. So $500 million in year 1 divided by 1.05 plus $400 million in year 2 divided by 1.05 squared. And so why did I square the denominator? Well, if you think about it, imagine you have $100 in a bank account, and this bank account accrues interest at 5% per year. After 1 year, you're going to have $105, and in the second year, that $105 is going to accrue interest at 5% again. And so there's going to be interest on the interest. So this is called compounding. And so to calculate how much money we would have in this bank account after 2 years, we would take $100 and multiply it by 1.05, and then multiply it by 1.05 again, so 1.05 squared. And similarly, if instead of calculating the future value, we're calculating the present value, instead of multiplying by 1.05 squared, we divide by 1.05 squared. Okay, so along the same lines, we get $300 million in year 3 divided by 1.05 cubed. And so if we compute everything, we find that this project has an NPV of $98.2 million. Now let's do the same thing for project B. The NPV of project B is going to be equal to minus 200 minus 200 over 1.05 plus 300 divided by 1.05 squared plus 300 divided by 1.05 cubed. And again, if we multiply everything out and do the summation, we find that this project has an NPV of $140.8 million. And so if this drug company could only decide between one of these two strategies, and they were basing their decision based off of which one had the largest NPV, then they would go with project B.